Worldwide, cardiovascular disease affects the lives of hundreds of millions. Dedicated cardio nerds everywhere are working hard to fight this global epidemic. These are their stories.
My fellow cardio nerds, it's Amit Goyal. Welcome back to the evolution of the neurohormonal hypothesis with the legendary Dr. Milton Packer. In this 6-part series, Dr. Packer takes us through the arc of the inception, the present, and the future of the neurohormonal hypothesis in the management of patients with heart failure. In this 4th part, we get to hear his perspectives on the revolutionary SGLT2 inhibitors. We discuss the mechanisms of action and the data regarding their role in the care of the heart failure patient. Well, this is a particularly historic episode because Dr. Packer shares his thoughts about the Emperor-Preserved trial well before the data was available. As you will recall, Emperor-Preserved was a large trial that randomized nearly 6,000 patients and showed that in patients with class 2 to 4 heart failure and an ejection fraction above 40%, the SGLT2 inhibitor Empagliflozin reduced the primary outcome, a composite of adjusted cardiovascular death or hospitalization for heart failure, which was primarily driven by reduction in heart failure hospitalizations rather than mortality. While we still await a treatment that shows clear mortality benefit in patients with HFpEF, this was a landmark study. In the episode description, you can find links to the primary article, as well as a DocWire news article written by CardioNerds Correspondent Dr. Mark Belkin. For Dr. Belkin's article, Dr. Packer provided the following exclusive quote: "We are pleased to have the first trial in patients with HFpEF that shows an unequivocally positive and clinically important result. We are looking forward to many secondary papers that will provide detailed information about what we have found and what it means for patients." So my friends, strap in and let's dive in together to the historic story of the SGLT2 inhibitors. But before we do so, remember that CardioNerds is an independent, fellow-founded educational platform with a mission to democratize cardiovascular education. The views expressed here do not reflect the opinions or policies of our employers. Help others find us by rating and reviewing the show. And now, let's get nerdy.
So our next question is kind of still in the realm of dark horses. It's about SGLT2 inhibitors. They've arisen unexpectedly as another pillar of heart failure management. I know most recently you led the Emperor-Reduced trial that showed positive outcomes in the HFrEF patients receiving Empagliflozin, regardless of their diabetes status. So we have a couple questions about this. The first is, at what point in the story did you think that it could be a good foundational treatment for heart failure? And the million-dollar question is, what do you think the mechanism of action for this benefit is?
Oh, I'm so glad you asked that. Okay, let's hold the mechanism of action. Just if you, with your permission, let's hold it for 2 minutes. Is that okay? Because I have a great explanation for how the drugs work. But 2 minutes, just 2 minutes. So SGLT2 inhibitors really, remember, these were drugs for diabetes. And they don't lower hemoglobin A1C very well. They're pretty modest in terms of an anti-hyperglycemic effect. But every single cardiovascular outcomes trial in diabetes showed a reduction in heart failure events and a reduction in kidney events. Every single one. Every single one came in with almost exactly the same point estimate, a 30% reduction in heart failure hospitalizations. That's not a small effect. That's a really big effect. And so what's very funny is John McMurray and I, who've collaborated on so many trials together, and he and I were co-PIs for the Paradigm trial. For SGLT2 inhibitors, we both led SGLT2 inhibitor trials, but with different ones, with different sponsors. John led the DAPA-HF trial with dapagliflozin, and I led the Emperor-Reduced trial with empagliflozin. They were, we call them sister trials. Sister trials that were led by brothers. It's sort of a nice way of thinking about it. And they came out with identical results, 30% reduction in heart failure hospitalizations, point estimate almost exactly the same as the point estimate for heart failure hospitalizations in the diabetes trials. So really, really consistent reduction in renal events, just like in the diabetes trials. We are about 30 days away from seeing for the first time the results of the Emperor Preserve trial. 30 days. So Emperor had two trials, one in reduced ejection fraction, one in preserved ejection fraction. In the reduced ejection fraction trials, people had ejection fractions of 40% or less. In preserved, they had ejection fractions greater than 40%. Same group of investigators, same trial infrastructure, same case report forms, same endpoints, same adjudication process, parallel trials. Emperor Preserved is a bigger trial. It's close to 6,000 patients. And we're planning on presenting the results of that trial at the European Society of Cardiology meetings in August. We have no idea what the results are. We expect that to see the results for the first time in early July. Because of SEC regulations, there will be a press release at the time. So the world will know what our top-line results are even before we present them at the European Society of Cardiology meetings at the end of August. And if you ask me what my expectations are, I will say, we'll see. Remember, the whole idea is to underpromise and overdeliver.
So, Dr. Packer, real quick, CardioNerds have started a medical journalism program where our residents and fellows, and Mark Belkin is one of them, is a CardioNerds correspondent who cover the latest breaking trials and important news coming out in cardiology. So maybe we'll circle back to you for your comments after the results have been hopefully over-delivered.
We will see. We are waiting with great expectations. And if we replicate the heart failure event endpoints in the diabetes trial, then this will be the first really effective treatment for heart failure and preserved ejection fraction. It would change clinical practice, but we'll see. Before we get close to even thinking that, we actually would be nice to see some results. So we will see that. So you asked me, how do these drugs work? So the politically correct answer is, there are two politically correct answers. Both of them are absurd. The first politically correct answer is, we don't know. The second politically correct answer is, it's multifactorial, which is the same as saying we don't know. So anytime someone says multifactorial, it means they don't know.
Dr. Packer, it sounds like you're saying that we do know something, though.
Well, so I think we may know something. So there's a lot of basic science work on what SGLT2 inhibitors do. And if you think about it, just think about what SGLT2 is. It is located in the proximal tubule. And when you have too much glucose, it allows you to regulate how much glucose is in the urine. It's basically a nutrient sensor. If you have excess nutrients, it's upregulated. If you're nutrient deprived, it's downregulated. It's one of the body's nutrient sensors. If you inhibit it, what happens? Well, you spill glucose in the urine. Do you spill a lot of glucose? You spill a lot of glucose, and you spill it every day. You lose massive amounts of calories when you give an SGLT2 inhibitor. You lose it in urine. Now, So what does the body do when it loses calories? What the body does is it upregulates nutrient deprivation sensors. One of the central sensor mechanisms is a molecule called sirtuin-1. Sirtuin-1 is really interesting because all it is a deacetylase. But it deacetylases hundreds of proteins, basically converts the activity of proteins in order to create a homeostasis state during states of starvation. And so, does that do the body any good? Well, one thing that's really interesting about starvation is that regardless of where you are on the evolutionary scale, starvation prolongs life. If you starve worms, they live longer. If you starve mice, they live twice as long. If you starve any species, they live longer. They live longer because their organs are protected, because sirtuin and its downstream effectors are incredible at reducing cellular stress. Essentially, during starvation, the body says, uh-oh, I'm in trouble. It's time to shift from a growth program to a survival program. When nutrients are plentiful, growth is prioritized. When nutrients are in short supply, survival is prioritized. And sirtuin-1 is the master molecule that drives that. So would you be surprised to learn that SGLT2 inhibitors upregulate sirtuin-1? And they reduce cellular stress. And they reduce cellular stress, particularly in two organs. One's the heart, one's the kidney. Why? Because those are the two organs with the greatest oxygen requirements in the body. They're the two organs with the greatest amount of cellular stress. And so don't be surprised that when you're in a state of nutrient surplus and sirtuin-1 is downregulated, the heart and the kidneys suffer. When you go into a state of nutrient deprivation, the heart and the kidneys are protected. Essentially, what SGLT2 inhibitors do is they fool the body into thinking it's being starved. They induce a state of starvation mimicry.
Very interesting, the way that combines both the heart and the kidney. And I'm interested to see future basic science studies that start to sort all this out. Kind of to change gears a little bit from the GDMT.
Well, there you have it, Dr. Packer's perspectives on SGLT2 inhibitors. Be sure to come back and join us for part 5, the ejected fraction of a destroyed heart. Now, it's time to make like an S2 and split.